I want to say that I am really, really humbled and excited, and I'm very, very happy to be here today. And I'm also humbled very much by the previous speaker, because this is an area, this is an aspect of climate change that I am almost not familiar at all. So it's really great to have those conferences where we can come together, not only from different continents and different countries, but also from different areas of expertise. Many of us, I think, spend most of our life inside of our departments, our research labs, our disciplines. And although we might think that we know a lot about climate change, it's when we come to those meetings and we talk and we are face to face with our colleagues who are doing completely different research. This is really when important discoveries and important moments are happening for us, when we realize that climate change is much more than just our narrow area of research. So I wanted to take this opportunity to express my thanks first of all to OMICS, and particularly Dr. Iaconti. I see him running from one conference to another, and I think we really have to applaud his efforts bringing scientists from around the world around many important problems that we face today. Not only climate change, but I understand there are, I think, at least two different conferences that are happening at the same time as we are working in this room. So I think it's very, very commendable. I'm also very happy to see that this is a small conference. It's very different, I think, from what we experience usually, again, within our professional organizations, where we're running between 10 different or 20 concurrent sessions and have little time to talk to each other. So I want to encourage all of you to take an opportunity to have conversations, to reach to each other. We have 3 days. We're a very small group of people. And I think the most important things are going to happen not during our 15 or 20-minute presentations. The most important sharing of ideas is probably going to happen during the coffee breaks, during lunches, during informal discussions, at the bar. This is really where I think the real conversations are happening. And I really want to encourage you to reach to each other and go beyond the disciplinary boundaries, because this is really what this conference is about. So the recent report of IPCC has just arrived, end of 2013, the beginning of 2014, depending on the working group. And of course, once again, we have very solid confirmation confirmed by hundreds and hundreds of peer-reviewed articles that warming is happening, climate change is unequivocal, the total radiative forcing is positive, and it is now very well, we can be very, very confident about the fact that at least the majority of climate change that we are experiencing during the past century is most likely due to the increase of CO2 and other greenhouse gases. I, however, want to again to emphasize that we want to see many other aspects of climate change and not focus necessarily only on the increase of greenhouse gases, because we also need to see in the picture other aspects of climate change, natural aspects of climate change, land use, urbanization, and so on. But we clearly see, regardless of the area where each of us is working, we clearly see that the global temperature is increasing, and it's obvious that there is a very strong connection between the increase of CO2 and other greenhouse gases in the atmosphere and the increase of the temperatures that we observed during the past 2 centuries, and particularly during the past decades. It is unequivocal. We have a clear scientific evidence that climate is warming, and we have never experienced in the past thousands of years, hundreds of thousands of years, in the recent geological past, we have never experienced the level of CO2 concentrations that we are facing today. So just a year ago, actually, we could see that their concentrations of carbon dioxide have jumped over 400 ppm. I don't know how many of you have noticed, we have been like, for decades we have been talking about high 300s, and we are already in low 400s. So it's happening really, really quickly. And just in one generation, we are, I think, changing the attitude to climate change. We are moving from climate change being a scientific problem, being something that we observe from the scientific data, to climate change becoming an everyday reality, a climate change of the common people who are not necessarily interested in climate change, but who are living through climate change. So we are really getting into that time when climate change is a part of our everyday life. And even though there might be significant disagreement about what would be the climate change scenarios for the next half a century or century, being based on different models and different emission scenarios that we use, there is a fairly good agreement between all existing models from different climate research centers all over the world. There is a good agreement with instrumental data. There is a good agreement with historical data that we see very significant temperature raise due to increased concentration of greenhouse gases. So regardless of what is your area, and I see in the program that we see scientists here who are working primarily with paleoclimate change in the past. We see, some presentations during the next 3 days focusing primarily on meteorological data, on instrumental records. And we also see a number of people in this room who are working primarily on climate modeling and developing climate change scenarios and working with applications of climate models, exploring impacts of climate change on food security, water resources, coastal development, and many other aspects. So with all these different data coming from different disciplines, I want to emphasize the fact that today we are really primarily probably concerned with climate change, not so much because we are noticing these few degrees of warming. Climate change is not so much about warming. Climate change is increasingly about growing extremes. We are going into more and more unstable climatic system. So if we look just back into, let's say, 10 years, maybe 15 years ago, we would see that things that used to be some kind of statistical abnormality, something unusual, something very strange, being a major deviation, they are becoming a norm. We are clearly seeing more and more unstable system with more and more extremes. I don't know how many of you remember, huge heat wave that affected mainly France, but many other Western European countries in 2003, resulting in almost 70,000 deaths, mainly elderly people, mainly urban dwellers. But these kind of heat waves, they are unfortunately becoming a norm in many parts of the world. I don't know how many of you, my colleague from Novosibirsk probably remembers the events in 2010 in Russia. I was not in Moscow. I'm originally from Russia also. I was not there in 2010, but I was there in 2011 when the consequences of the heat wave of 2010 could still be seen on all levels of the society. And so again, somewhere between 56 and 60,000 deaths just in one summer as a result of forest fires and as a result of heat wave in the European part of Russia. Again, these kind of events that are seen today as statistical meteorological abnormalities, something extreme, they're really becoming a norm. And this is scary. This is something that needs to be taken into account because they are becoming a part of our everyday reality. Again, another heat wave that had a huge impact on food prices around the world that hit a year ago North America, when most of Midwest and Great Plains were seized by a huge heat wave in July and August 2012. Not as dramatic as the heat wave in Russia in 2010, but huge impact, again, huge impact on the price of food with the repercussions around the world. And of course, when we're speaking about the climate extremes, it's not just about heat waves. It's droughts and floods, and paradoxically also it can mean cold waves. So this is my home city of Grand Rapids in West Michigan. Grand Rapids is the second largest city in Michigan after Detroit. It's also it has a reputation of one of the most sustainable cities in the United States. And so this is Grand Rapids at its normal, during its normal year. This is Grand Rapids last year when we had our 100-year flood, and the city was really terrified because downtown was completely inundated. Again, the question is how often we would experience those, what we consider 100-year floods, because 100-year floods are becoming 5-year floods for some regions. So we really need to rethink the way how we are addressing our extremes. We still tend to see, climate policy as one thing, FEMA as another thing, right? We are still seeing a huge difference. We don't necessarily, our decision-making system is not necessarily putting together the natural disasters, response to the natural disasters, and climate change policy. So it's really time to think about it. And as I said, climate change, climate extremes, it's not necessarily just women. This is how Great Lakes look this year, and this is me. This is a picture taken by my 11-year-old daughter, and this is Lake Michigan. Lake Michigan stopped having permanent ice cover for many years, and it became in the past years almost subject of excitement for transportation industry, because it means, the loss of the ice cover could mean an opportunity for transporting goods across the Great Lakes. Well, this year we had 97% of Lake Michigan was frozen. About 89% of the entire system of the Great Lakes was frozen. And of course, those of you who are from the Eastern Coast or from Midwest, you know that that was a pretty horrible winter, right? What is the connection between warming and extremely cold winter in the Midwest? Well, there is a mounting amount of data, there is a mounting evidence that it's a very logical connection, because as the Arctic is losing more and more ice, and the entire circulation system around the North Pole is becoming more and more unstable as a result of the loss of permanent ice cover within the polar circle, we would see most likely more and more of those deviations of the Rossby wells, going maybe 1 year to Russia and 1 year to Michigan and 1 year to France, and so we'll see more and more of those winter abnormalities during the next few years. So we're really talking about the extremes, and we have huge number of data showing that the extremes are growing around the world. We see that the severity of these extremes is growing around the world, that it be floods or droughts. We also see more and more catastrophic storms. Again, another statistical first, another event that was considered impossible until November 2013. I'm sure that you all remember Typhoon Haiyan that caused more than 6,000 deaths in the Philippines and other countries of Southeast Asia and the Pacific. And that was the fastest, the largest storm ever in the history of meteorological data. I don't know how many of you remember that just during the same month of November 2013, there were two other very destructive storms, not as destructive, but also causing few deaths, dozens of deaths, one in the Midwest, one in England. I don't know how many of you remember, November in UK this year. It was another very unusual storm. So we have this growing number of major weather events that is very difficult not to associate with climate change. A considerable number of this really destructive burden of climate change falls on the countries that cannot afford necessarily adapting very quickly to changes in meteorological conditions. This is another map showing the deaths attributed to climate change, not because of the extremes. It doesn't take into account the events that I have just shown. This is the number of deaths attributed to climate change just because of the changes in their health conditions, food security, access to water, and primarily burden of the vector-borne diseases. So again, we see quite a huge difference between developing and more developed and less developed countries, where the infrastructure really is going to say a lot about what would be the implications of climate change. So we really need, once again, I want to say that we need to think beyond our disciplines, because climate change is not just about geoscience, it's not about earth science, it's not about our scientific discoveries. It's very much about how we can implement what we know about climate change in more meaningful climate policies. So we need to work with social scientists, we need to work with economists, we need to work with sociologists, we need to work with political scientists in order to have really a full picture of what can be done about climate change. When we are looking at the projections, when we are working with climate models, with so-called GCMs, we can have a fairly good idea of what would the scenarios mean in terms of increasing number of floods, increasing number of heat waves, food security for different parts of the world. So it is clear that in the next few decades, our children, our grandchildren are going to carry a higher burden of climate change through those catastrophic events. Changes in the water availability are happening already around the world. This is one of the projections by the IPCC. Very significant changes. And changes in the agriculture that would have profound impact on food security of the world. This is something that needs to concern us the most. And again, when we see the difference between developing and developed world, we see very significant difference between the burden of climate change in terms of its implication on food security. Climate change, paradoxically, can be a source of benefits for some reasons, for some regions of the world, but it can also be a very source of threat for others. And so we need more data, we need more information about how climate change is affecting different agricultural crops and what are the methods of adaptations. My own research is primarily focused on food security in the countries of the former Soviet Union, in my native Russia, and also countries of Central Asia. And so Russia is actually one of the countries that is benefiting right now from climate change. And in the past 10 years, weather conditions were very favorable for this region, and this is something that allowed many countries of former Soviet Union to position themselves as the leading producers of wheat and corn, primarily wheat, and Russia is projected to surpass the US probably within a couple of years in terms of wheat productivity. But the question is how all this is going to affect, the entire geography of food prices, what regions would benefit, what regions would lose as a result of those changes. from here, I want to go straight to asking you to think about what are the implications of those future climate changes for our ability to live with them and to adapt, even if we know that we need to continue working on mitigation of climate change. The question today is also how to not only to mitigate, but how to live with it, how to adapt. And we need to remember that these changes are happening in the context of many other changes that are happening simultaneously without being related to climate change. So as we are speaking about climate change, it's possible that in another room someone is talking about urbanization. What is the connection between urbanization and climate change? Well, there is a direct connection, right? Because the number of people living in the world is now bigger almost everywhere than the number of people living in the rural areas. And the growth of urban population, particularly in the developing world, is going to continue at a very fast pace. What does it mean in terms of climate change? Well, usually when we focus on the climate change projections, we don't really look in depth what is the land cover, what is land use of those areas. But you know all well, just as myself, that cities are the urban heat islands. And so when we are speaking about climate change of order of 2 degrees, it's really order of 5 degrees or 6 degrees, because the majority of the population is experiencing this climate change in the cities. So the same climate change scenario would look very different for urban dwellers, for slum dwellers, because the slums around the large cities of the world are growing extremely fast. And people who are living there are many, many more times are vulnerable to climate change compared to people who are living in suburbia. There is a huge difference in the rural areas, there is a huge difference in our responses to climate change compared to where we live. So here are just some projections of probabilities of heat waves, similar to very well-known Chicago heat wave that in many ways changed our thoughts about urban planning and what the city should look after many people went through the heat wave of 1995 in Chicago. In many ways, it had profound changes on thoughts about urban planning in Midwest and in the US in general. I mentioned the heat wave in Russia in 2010, and this is how European part of Russia looked at that time. Those are satellite images and pictures of the city, and what you see, the difference between the transparency of the atmosphere in the normal year and during the heat wave. What you see here is the smog from the forest fires, smoke from the forest fires happening around the city. So again, vulnerability of the urban dwellers is significantly higher. The same is true when we are speaking about the floods. The same is true when we're speaking about the droughts. So climate change might mean very different things for different parts of the world and for different parts of the population. And in order to understand how to deal with this, we really need better metric of human vulnerability. And this is really the last idea of my presentation today. What can we do to measure this variety of different responses? And although there are many different approaches to measuring human vulnerability to climate change, there is today a good agreement that we need to focus on 3 aspects of climate change, 3 aspects of vulnerability to climate change. Exposure, and exposure is primarily determined by where you are, your physical geography, the ecological parameters of the area where you are. Simple things such as elevation, proximity to the source of disaster, Is it a coastal area or no? Altitude, and so on. Sensitivity. Sensitivity to climate change is determined not by physical parameters, but mainly by sociology and demographics. Have mounting number of data from around the world showing that women might be significantly more vulnerable to climate change in many cultures compared to men. That children and elderly are clearly more vulnerable to climate change. That in different societies, depending on how they're organized, we have groups of people who are significantly more vulnerable to climate change, more sensitive to climate change than others. So sensitivity is really about social structure of the society. What do we do about climate change? Do we provide the same relief from climate change to everyone? It's very much the question of environmental justice. And finally, adaptive capacity. Again, adaptive capacity to climate change is not determined by how much we know about climate change in terms of geoscience. It is determined by economics. That's why I'm very happy that we have some sociologists and economists here, and not only pure atmospheric scientists, because we can have those conversations. Adaptive capacity is about access to resources. So depending on how much money we have, how much education we have, what is your access to technology, what is your access to media, what is your access to your local politician, what is your decision making, what is your influence on decision making, your adaptive capacity might be very, very different. So there are really many dimensions of human vulnerability to climate change. Some of them physical, some of them social, some of them institutional, some of them cultural, some of them economic. We need very full picture of all these different dimensions. I know that I'm almost running out of time, so I'm going to show a couple of slides with implementation of the scheme that we have developed for the countries of Central Asia, for the countries of the Aral Sea Basin, Uzbekistan, Turkmenistan, Kazakhstan, Tajikistan, and Kyrgyzstan. This is a part of our study that I've just published in Earth and Environmental Science. So not only we need different indices, different quantitative indices for exposure, sensitivity, and adaptive capacity, we also need to look at them at different scales. They're very, very scale sensitive. So indicators relevant to impacts of global climate change can be very different to the indicators for exposure, sensitivity, and adaptive capacity relevant to regional changes, because regional climate change is happening not only because of the general changes in the atmospheric circulation, it's changes because of also, this includes changes in land use and land cover, it includes local and regional hydrometeorological changes. And these metrics can be very different depending on the sector, what kind of metrics we need for water availability. We might need different metrics for food security. We need different metrics for human health, and so on. So this is something that is, I think, extremely important, how we can build those frameworks in order to understand and measure and map the responses of different regions to climate change at the global and regional and local level. And with this, I want to come back to Grand Rapids, Michigan. And I want to mention Grand Rapids because we are one of the first cities in the US who has replaced strategic planning by sustainability planning. And the city just developed a year ago its first assessment of resilience to climate change at the local level. So we worked with local, regional, and global climate change scenarios for the region, for the entire region, and for the city. And we have developed metrics of economic, social, and physical and ecological parameters in order to determine what is the level of resilience and what is the level of vulnerability to climate change and I believe this is just the very first step, but this is the step in the right direction. So with this, I want to conclude, and I hope again that we'll have many great conversations, both during the sessions and especially between. Thank you.
Thank you, Elena, for the great speech that you have given us. And then I would like to acknowledge your participation in this event with a certificate. Thank you.
Thank you so much.
Thank you very much. Okay.